Hey everybody, so in this video we are going to look at another example of graphing linear inequalities. If you haven't watched the first video on this, you definitely need to do that before you watch this one. Okay, so let's go ahead and look at our current example. We're going to graph the solution region. We're going to go ahead and finish this example out here. So we're going to graph the solution region for y is less than or equal to 2x minus 4. Okay, so again, the first thing we're going to do is graph the border, which comes from the associated equation, y equals 2x minus 4. Okay, now in the previous example, because our equation was in standard form, we used the x and y intercepts to graph. Because this is in the y equals mx plus b, or the slope-intercept form, I'm going to go ahead and use the slope and the y-intercept. So my slope is 2, or 2 over 1. And my y-intercept is, well, my b value is negative 4, which makes my y-intercept 0, negative 4. Okay. So I'm going to start with the point 0, negative 4, 2, 3, 4. That's right here. Okay, and then I'm going to find other points by doing the slope 2 over 1. So up 2 and over 1. Okay. I'm going to graph some more further away points so that when I go to do my line, I have something to start with. Okay, so here's another point on my line. And there's another point on my line. Okay, so let's go ahead and connect these using a line. Okay. Move this a little bit. There we go. Okay, so there's my line connecting my points. All right, so now I want to describe if this is going to be solid or dotted. Okay, so I will remind you guys how we decide that. Okay, so if we have greater than or equal to or less than or equal to, that means that the line has solutions on it. I guess I will say the points on the line are solutions. Okay, which means that we want to use a solid line. Now, if you have greater than or less than without the or equal to part, this means that the points on the line are not solutions. Okay, and in that case, we want to use a dotted line. Okay, so in our example, we have less than or equal to. We have less than or equal to, so the line is solid. Okay, so we're just going to leave it the way it is. Okay. The next thing we're going to do is test a point. Okay, so let's make some room for ourselves to test a point here. And I'm going to emphasize, like I did in the last video, that the point you're testing should not be on the line. Okay. Now, last time we tested the point 0, 0, okay? This time, I would like to test a different point just so that you see you could test any point. So let's just test this point way over here, okay? So we are going to test the point 7, 0, okay? You can test any point that's not on the line. Like I said, usually people pick 0, 0 just because it's so easy to plug in. Okay, so if we test this, we plug in 0 for y, 7 for x, okay, and I have 0 is less than or equal to 14 minus 4, or 0 is less than or equal to 10. Okay, now this is true. Okay, so 7, 0 is a solution. So what we want to do is shade in the part of the graph that includes 0, 0. So last time we talked about, or I'm sorry, 7, 0. So last time we talked about how if it wasn't a solution, we wanted to shade the other part. Now, if this is a solution, we're going to shade in the part that includes that. So this is going to be this part down here, okay? So that means that all of our solutions are down and to the right here. Okay, that's it for this example, so I will see you guys in class.